It is usually known that work is equal to change in kinetic energy. But the real question is, how do we get to that answer? We can start by describing work as the force times the displacement of an object, or basically the force applied through a certain distance. And the certain distance is going to be equal to x final minus x initial. Then we can rewrite work as an integral. It is going to start from the initial position to the final position, and it's just going to be the force applied in that distance. We have two equalities right here. Then I can make the integral more specific, saying that force is equal to mass times acceleration. Mass goes apart because it's a constant and we're taking it with respect to a distance. And we can still add details. We can express acceleration as the derivative of velocity over time, and velocity as the derivative of position over time. Here, if we multiply it out, we can see that dx is equal to v dt. We can plug in both variables, having m times the integral from the initial position to the last position, times the acceleration times dx, which is going to be equal to v dt times dv over dt. Dt cancels, and we are end with v dv times the mass as our integral. But there's a problem. When I rewrite this expression, this basically doesn't make sense. We cannot rewrite an equation of velocity in plug-in position. So we need to rewrite it from velocity initial to velocity final. And we're going to get that from the first equality, which was velocity equals to the derivative of position over time. Then we can solve for the integral. It is just a polynomial, and we end up with mv squared divided by 2 from v initial to v final. And that takes us back to our first equality. Work equals to change in kinetic energy.